Hi, grade 12. Today we are doing the supplementary exams of June 2021, and I will be doing geometry with you. We will be starting with question 8. So the question reads 8.1 in the diagram, MP is the diameter of the circle. So MP is the diameter of the circle centered at O, and angle R1 is 69. And that is indicated on our diagram. Our questions are determine giving reasons. So we have to give reasons. The size of 8.1.1 angle R2. This is R2 over here. Do you remember grade 12? Let's say you have a diameter like that. If you have a point on the circumference and a point on the circumference, and you take both these points to the circumference, that whole angle there is 90, angle in a semicircle. I'm going to do the same thing here. Do you see this point on the circumference and here on the diameter? So I'm going to go here and I'm going to go here. And do you see that this whole angle is 90? Angle in a semicircle. So let's write that down. So for 8.1.1, I'm going to say R1 plus R2 must give me 90 degrees. And the reason, angle in a semicircle. R1 is 69. So 69 plus R2 is then 90. So R2 is 90 minus 69. Angle R2 is therefore 21 degrees. So then I go to my diagram and I put in here, this is 21 degrees. Okay, let's look at the next question. 8.1.2 says calculate the size of angle O1. O1 is at the center over there. Because it's at the center, I'm going to look for angle at center twice angle at circumference. So this one is twice this one. Let's see if we can find something like that. So O1 is here at the center. So from that, I'm going to go down to the circumference. And then from these points, I must go somewhere up to another angle. From there to there, look here. So angle at center, this angle is twice this angle. Let's write that down. 8.1.2, angle O1 is equal to double 69. My reason, angle at center twice angle at circumference. Therefore, angle O1 is 138 degrees. Okay, so let's put that in. And our next question, 8.1.3 says calculate the size of angle M1. Let's go look where M1 is. So M1 is this angle over here. I am going to use the fact that M1 is in an isosceles triangle. If you have a radius like that, so that's a radius and this, they are equal in length, eh? So that means you have a little isosceles triangle, which means the base angles are the same. So let's look, where's the radius? M is a radius and ON is a radius. They are equal in length. There I have a little isosceles triangle over there. That means the base angles are the same. Let's write that down. 8.1.3. I'm going to say angle M1 is 180 minus 138. And that answer, I'm going to split that answer in two for the base angles. So I get that angle to be 21 degrees. Okay, so that one is 21. So my reason is radii. Okay, so that was one way of doing it. So another way to do this question was I go to M1 and I go down until I get to the circumference. So there it hits N and it hits P. But N and P can also go somewhere else. N can go here and P can go there. So do you see the butterfly? angles in the same segment. So M1 is also 21 degrees. Angles in the same segment. The last question is 8.1.4. So we are here and it says calculate the size of angle M2 if it is given that NO is parallel to PR. So let's highlight that. NO, so this line is now parallel to this line. Okay, so I'm going to make this line parallel to that one. We have to calculate the size of angle M2, so that angle over there. So I'm going to plan, and before I get to M2, I'm going to work out other angles first. So grade 12s, do you know if you have a Z like this and this line is parallel to that, then this angle is equal to that, alternating angles. So can you now see the Z over here? So that means this angle is equal to that angle. Can't we work out that angle first? So I'm going to work out angle 2 first, and I'm going to use angles on a straight line for that one. Then once I have O2 over there, I'm going to work out this angle here. I'm going to work out angle P, alternating angles. And then I'm going to work out the angle in the question, which is M2, using this triangle. And I'm going to do the interior angles of a triangle since this is 90. And I will have this angle over there. So then I'm going to work out angle M2. So that's the plan. I'm doing 8.1.4. Angle O2 plus 138 degrees will add up to 180 degrees. And my reason is angles on a straight line. Therefore, angle O2 is 180 minus 138. And that gives me 42 degrees. This angle here is now 42 degrees. And if O2 is 42, then P is also 42. Therefore, angle P is also 42. And the reason is alt angles and the lines that are parallel is NO is parallel to PR. Then after that, I'm going to work out angle M2. So in the blue triangle, M2 there on top, plus the 42 that we worked out, plus the 90 that we've worked out, is equal to 180. And the reason, angles in a triangle, so angle M2 is 180 minus 42 minus 90. And I get angle M2 to be 48 degrees. And that was the last question under question 8. Okay, let's do question 8.2. It says in the diagram, ABCD is a cyclic quad. A, B, and DC are produced to meet at E. Okay. AD and BC are produced to meet at F. Okay, so those two lines meet at E and the other two lines meet at F. Angle AFB is 2x, that's on the diagram. Angle DAB is 3x, that's on the diagram. And angle AED is x, that's also indicated on the diagram. And the question for 6 marks is determine, giving reasons, the value of x. Let's write our plan down. So there's many ways to do this question. Many ways. I'm going to show you one way. So I'm going to choose an angle and express that angle in terms of x. So I'm going to choose an angle and then I'm going to express the angle in terms of x. Then I'm going to use the same angle and I'm also going to express that in terms of x. But I'm going to use different reasons. So for the first one, I'm going to look for a reason. And for the second one, I'm going to look for another reason. And then I'm going to make them equal to each other. So that's my plan. Let's look if we can do that. So I have this angle over here, I have this angle over here, and I have this angle over here. So what other angle can I work out? So grade 12s, do you see that this is a triangle? I have two angles in the triangle. I have angle A, so I have this angle over here, and I have angle F. So can't I work out angle B2 in terms of x? So I'm going to write that down. I'm going to say angle B2 plus 3x plus 2x. So I'm saying this plus that. They must add up to 180. Angles in a triangle. So angle B2 is then 180 minus 3x minus 2x. So simplified, angle B2 is 180 minus 5x. So I've expressed an angle in terms of x. Can you see there's the x in it? And I've used, my reason is angles in a triangle. So now I'm going to look for another way to work out angle B2, but I'm going to use a different reason. I'm going to work out angle D2, and then I'm going to work out angle B2. So angle D2 is in this triangle. So I'm going to write angle D2 plus x plus 3x is equal to 180 angles in a triangle. So angle D2 is 180 minus x minus 3x. So angle D2 is 180 minus 4x. So this is 180 minus 4x. So I wasn't looking for D2. I'm actually looking for angle B2. So to get to B2, I'm now going to refer to the information that said ABCD. This is a cyclic quad. And what do we know about cyclic quads? They're opposite angles. So angle D2 and this whole B2, they must add up to 180. Let's write that down. I know that B2 plus D2 is equal to 180. Can you see here's the different reasons? Opposite angles of a cyclic quad. There's my other reason. So B2 plus D2, we worked out here's angle D2. D2 is 180 minus 4x. So 180 minus 4x, that must be equal to 180. Angle B2 is 180 minus 180 plus 4x. So angle B2 can also be expressed as 4x. I'm going to highlight for you. This is angle B2 and this is angle B2. Can you see? I have different expressions. So if angle B2 is this, but angle B2 is also that, then they are equal to each other. So let me write that down for you here. So angle B2 is 180 minus 5x. But angle B2 is also 4x. That means if this is B2 and this is B2, they are equal to each other. And I'm going to make them equal to each other. So I'm going to say 180 minus 5x must be the same as 4x. And then I'm going to solve for x. 180 is 4x plus 5x. 180 is equal to 9x. Divide both sides by the number in front of x. So x is 20. And that was the question. Determine the value of x. Many ways to answer that question, but that's one way of thinking about it. Let's look at 9.2 grade 12. It says in the diagram, M is the center of the circle. It also says that AC is equal to BC. It also says PA is a tangent to the circle. Then it also says that PQ is parallel to CA. That's indicated. And it says let angle Q1 be X. And question 9.2.1 says determine, giving reasons, 4 other angles that's also equal to x. So it was given that angle Q1 is x. And as you can see, grade 12s, angle Q is on a parallel line. So this line is parallel to that line. So I think that's our first step. So if we had to highlight this line here, do you see the transversal? I'm going to take it out here. If you have two lines that are parallel and you have this line transversal, do you agree that this angle and this angle are the same corresponding angles? Remember, the red lines are parallel, eh? This angle and this angle, they are equal. So angle A1 is also x because of corresponding angles. So let's write that in 9.2.1. Angle A1 is x. Corresponding angles, PQ is parallel to CA. So the information said that this line is equal to that line. Do you see the isosceles triangle? That means the base angles are the same. That means angle B there is also x. That's my next angle. Angle B is also x because of angles opposite equal sides. Okay, now I'm going to go from angle B. So angle B is here on the circumference. So I always try to go down from that angle to a chord. Can you see I can go to AC? And AC can make a triangle like that. But A and P outside here is a tangent. So do you remember this theorem? If this is a tangent, then this angle is equal to that. Tan chord theorem. So that means this whole angle is equal to that angle. Tan chord theorem. So let's write that in. That means angle A2 is also x. That is tan chord theorem. So far we have 3 angles. We need one more angle that's also equal to angle x. Do you see here where A2 is? Because that was the last angle we worked out. A2 is by this line. And that line is parallel to this line. Do you see the Z here? If this is parallel to this, then this angle is equal to that angle. So this is parallel to that. A2 is equal to P. Angle P is also x. That's our last angle. Angle P is also x. And the reason is alt angles PQ parallel to CA. And there we have 4 angles equal to x. So there that information is in. Our next question is 9.2.2 that says prove that ABPR is a cyclic quad. How do you prove a cyclic quad? It's either you prove this angle plus that angle is 180. Then that is a cyclic quad. Or you prove that this exterior angle is equal to that one. Then this is a cyclic quad. Or you look for a butterfly and this is equal to that. Then this is a cyclic quad. So it's A, B, P, and R. A, B, P, R. Do you see here? I see a butterfly. Do you notice that this is equal to that? And therefore, that is a cyclic quad. We can just say 9.2.2. Angle B is equal to angle P. Both of them are equal to x. It was proven in the previous question. So therefore, A, B, P, R is a cyclic quad. Reason, now this is the important part. Remember to write converse. And because we use the butterfly, it's going to be converse angles in the same segment. Our last question under question 9 is 9.2.3. It says, prove that BA over BQ is BC over QR. So let's highlight many ways to do this question. You can use prop theorem or similar triangles. So it's BA over BQ. So it's BA over this whole BQ. And then it's BC, top here, over QR. Okay, but QR is over here. So I'm going to use the prop theorem to try and prove this one. So if we highlight this triangle over here, do you see this is a prop theorem triangle? Because this line is parallel to that line. So I'm going to say BA over the whole BQ. So let's write down 9.2.3 BA over the whole BQ is exactly the same as this top one over this whole one. So it's exactly the same as BC over the whole thing is BR. The reason is prop theorem, and the lines that are parallel is PQ is parallel to AC. Okay, now I've almost proven what they asked here. The only problem is this BR must be a QR. So that's a problem. So I need a plan to show that BR is the same length as QR. I need to prove that BR, I need to prove that this is the same length as this side. Now, if you have to prove two sides that are equal, do you see there we have a triangle. If you can prove that this angle is the same as this angle, then we can conclude that this side is equal to that side. Sides opposite equal angles. Okay, do you see that red triangle over there? Q is X. Angle B is X. So there's the base angles. That means QR is equal to BR. So there, my plan worked. So I'm going to write that in. So I'm going to write BR is equal to QR. My reason, sides opposite equal angles. Therefore, wherever there's a BR, I can now replace it with QR. So therefore, BA over BQ is the same as BC over, instead of writing BR, I'm going to write QR. And there I proved this question. And that's question 9. Look at question 10. It says TSR is a diameter of the larger circle. So there's two circles here. There's the larger circle and the smaller circle. And then it says chord TQ of the larger circle cuts the smaller circle at M. Okay. PQ is a common tangent to both circles. So PQ over here is a tangent to the small circle and the big circle. And RP is perpendicular to PQ. And MS is parallel to QR. That's all indicated on the diagram. So question 10.1 says, prove giving reasons. First one over here, that SQ is a diameter to the smaller circle. So you have to prove that this is a diameter to the smaller circle. So let's highlight the small circle. There. We have to prove that SQ is a diameter. How do you prove a diameter? If you have a circle and you see the endpoints of this line, let's say you have to prove this is the diameter. Then where this line goes and where that line goes, where they meet, that angle must be 90. And if it's 90, then this line is a diameter. So let's try and prove that. The plan is to prove that, so S and Q. So let's see, S will go to the circumference of the circle. Remember, we are in the smaller circle. Q can also go to M. We have to prove that this angle is 90. Our plan is to prove that M2 is 90 degrees. So remember, if you read your information again, TR is a diameter to the circle. So this TSR, this whole thing, is a diameter. So because that is a diameter, we have angles in a semicircle. So R goes to Q and T goes to Q, and Q is on the circumference. That means this whole angle is 90. And we know that this line is parallel to that line. So because they are parallel, isn't this also 90 then? Because of co-interior angles. So if you have two parallel lines and a line like that, this one plus this one is 180. So let's write that down, 10.1.1. So we started by saying Q1 and Q2, that whole angle is 90. And our reason is Q plus the whole Q1 and Q2 must be equal to 180. Why? Because of co-interior angles. And the lines that are parallel, MS is parallel to QR. That means M2 plus, remember Q1 and 2, this whole thing is 90. So M2 plus 90 is 180. So M2 is 180 minus 90, which is 90. And that was our plan, remember? So if M2 is 90, so remember our plan? If M2 is 90, then SQ is a diameter. Converse angle in a semicircle. So therefore, SQ is a diameter. But now we are going to say converse angle in a semicircle. Next question is 10.1.2. We have to prove that RT is equal to that expression over there. So let's write our plan down. I have to prove that RT is equal to RQ squared over RP. So I'm going to write RQ squared as RQ times RQ. Then I'm going to bring one of those RQs down. So it's going to be RT over one of those RQs. And then the other RQ is still left over RP. I want to prove this. I'm going to first see if this can make a triangle. Let's see if RTQ is a triangle. Yes, RTQ is this big triangle over here. So RTQ is a triangle. And let's see if this gives me RQP. Is that a triangle? RQP is this one over here. Okay. So I have two triangles. I'm going to say in triangle RTQ and triangle RPQ, I'm going to look for angles that are the same. So do you remember in the previous question, we said this whole Q1 and 2 is 90. So in the red triangle, angle Q is the same size as angle P in the blue one. They are both equal to 90, and that was proven. So the one was proven, the other one was given. Then let's look for another angle that might be equal. So grade 12, according to the information, QP is a tangent. And this is a chord. That chord makes a triangle that goes to T on the circumference. So according to the tan chord theorem, if this is the tangent then this angle is equal to that angle over there. So can you all see that angle Q3 is equal to angle T, tan chord theorem. In the red triangle, angle T is equal to angle Q3 in the blue one. And the reason is tan chord theorem. Tan chord theorem. So I just need one more angle. So let's quickly check. I've used Q and I've used T. I haven't used R. So my last angle is angle R. And in the blue one, I've used this P. So I've used P. This Q. So I've used Q. So I haven't used R. So in the red one, it's R1. And in the blue one, it's R2. And that will be my third angle. And now, therefore, triangle. So look here, grade 12s, I go QTR. Therefore, triangle QTR is similar to triangle PQR. So in that order, triangle PQR. And my reason is angle, angle, angle. And then I write my ratios down. So I go first 2 over first 2. So Q T over PQ is the same as last 2 over last 2. TR over QR is equal to first and last, first and last. So QR over PR. And my reason is because the triangles are similar. And if I look at my plan, you see, here's my plan. I had to prove this is this. Let's go look for them. So TR and QR, here they are. So it's this one and this one. So therefore, TR can be written as RT. Therefore, RT over QR can be RQ. This QR can be swapped. RQ over RP. And that means RT is equal to, I'm just going to cross multiply and take that over. So that becomes RQ times RQ is RQ squared over RP. And there I proved that question for 6 marks. Okay, the last question, 10.2, says if MS is 14 units. So if MS, that over there, is 14 units. And PQ is the square root of 640. So PQ, let's write this in. If this is the square root of 640, the question is calculate, giving reasons, the length of the radius of the larger circle. So the radius of the big circle is either we're working out TS, that's a radius, or we're working out SR, or we can work out SQ. So grade 12s, do you see that this is a prop theorem triangle? This line is parallel to that line. And because TS is a radius, so because this is a radius and this is a radius, they are equal in length, which means if I had to write a ratio down for them, it would be 1:1. So let's add a letter, 1K, 1K. Because they are equal in length, so this is equal to that. And the lines are parallel. In grade 10, we learned the midpoint theorem that said, if this is parallel to that, and this is equal to that, then this is also equal to that. And this is half the length of this. Midpoint theorem. So if this is 14, this length is 28. So let's write that down. That means QR is 28 units. I'm going to say TS is equal to SR. Radii. So I'm just writing everything down, eh? So therefore, QR is double 14. Midpoint theorem. So QR is 28 units. Okay, so far I have QR. Then, grade 12, do you see we have a right angle triangle here? I'm just looking for sides that I can work out. So can't I then work out RP using Pythagoras? So I think I'm going to do that next. I'm going to say RP squared is equal to, so I'm working out this side, is equal to the hypotenuse squared minus the other side squared. And that reason over there is Pythag. If you work out RP squared, you get 144. That means RP is 12 units. Okay, then I can go put this in as 12 units over there. Okay, so because I'm stuck, I'm going to go to the previous information. So do you remember we proved this over here? So in the previous question, we proved that RT is that expression, RQ squared over RP. So RT, this whole line, that's RT. Can't I work out that whole line? Then half of that is the radius of the circle because that's the diameter. So I'm going to write RT is RQ squared over RP. And this was proven in the previous question. RT is equal to RQ, so 28, squared over RP, which was 12. And that answer is 196 over 3. That's for the whole diameter. So remember, that is this whole line. This whole line is 196 over 3. But I don't want the whole line. I want half of the line because that's the radius of the circle. I'm going to take the diameter and I'm going to divide that by 2. And I get the radius to be 98 over 3 units. And that is the radius of the circle. And that's the geometry question of this paper, grade 12s.